Hello AP Physics folks, welcome to Chapter 3 Vectors. So, in Chapter 3, in the problems you'll see in WebAssign, there's really 6 main concepts that we'll go through. The first one is, and hopefully, by the way, these are all kind of review for the most part, maybe a few new things here or there, but hopefully you've seen a lot of these in maybe Algebra 2 or even Geometry. So the first main concept is SOHCAHTOA, and this is just the relationship between the sides and angles of a right triangle, sine, cosine, tangent. The second one is that the hypotenuse of a right triangle is the magnitude of a vector, where the legs of the right triangle are the components of the vector. The third concept is that when vectors are parallel, you can add them like regular numbers. So just like 7 plus 3 is 10, if you have a vector of length 7 and a vector of length 3, if those vectors are parallel and in the same direction, you can add them and get a new vector of 10. But if you have a vector of 7 and a vector of 3 that aren't parallel, then you can't just add them. You have to use Pythagorean Theorem and even maybe some more complex trigonometry. Speaking of which, main concept 4, when adding non-parallel vectors, you add like components first. So first you would break up your individual vectors into components, and the components would be parallel. Typically we break them up into a x and y axis component, so that all the x vectors, all the x components we can add just like numbers, all the y components we can add just like numbers, and then we can find the resultant of our vector. Resultant meaning the sum. Main concept 5, the negative of a vector is the anti-parallel of a vector. And main concept 6, the cross product of vectors. A cross B actually equals AB sine of the angle between them. Alright, so that's a little overview. Let's go into more detail for each of these separately. It should take 2 to 3 videos, I'm guessing. And then I'll do some sample problems for you from the book. Hopefully that hopefully contain all of these concepts. Okay, SOHCAHTOA. So, first this means sine, cosine, tangent. O stands for opposite. H stands for hypotenuse. A stands for adjacent. And what that means is if you have a right triangle, and this is the right angle, and say we're dealing with angle A, let's call it angle theta. That's gross. Angle theta, that's less gross. Then, and we have side A, side B, and side C. Then sine of the angle, sine of theta, is going to equal opposite, which the opposite angle of theta is B, over the hypotenuse, which is the longest side, C. Cosine theta equals adjacent, which is A, over C. And tangent of theta equals opposite, B, over adjacent A. So you'll use this a good amount when trying to find angles or trying to find lengths of a side, lengths of a component, or even the magnitude, the hypotenuse. So, and that's pretty much it. But another thing to mention is be careful when using an angle in here, because technically an angle can go all the way around to 360 degrees. 0 is pointing in the positive x direction, 90 is positive y, 180 degrees is negative x, and 270 is negative y. So just be careful with dealing with these. If you use your calculator correctly and you did something like sine of, like, I don't know, something between 90 and 180, so let's call it like 150. Then the sine is the opposite, so that's the y component. That's going to give you a positive value because it's giving you the y component of an angle over in this area. So 150 is probably like, so you start at 0 and you go 0, 90, 100, 110, 20, 150. So 150 might be here. Actually, it's probably a little closer to 180. So sine gives you the y component, the opposite component of that. Whereas if you did sine of an angle, say over here, then it's going to give you the y component of that, which is a negative. This is a positive value. It's going to give you a negative value. So if you type that in your calculator, and your calculator is in degree mode, then it should work. Otherwise, another way to think about it is that 150 is 30 less than 180. So you have an angle right here of 30 degrees, and just make a new, that's horrible, 30 degrees, and just make a new triangle in here. Let me try making the pen a little smaller, might be less messy. So yeah, 30 degrees. So anyway, long story short, you can use the full angles, or you can just think of this, let me use a different color so it's a little more clear. Think of this as like its own special little triangle, where this angle here is 30 degrees, which 180 minus 30 equals 150. Alright, so anyway, that's what I wanted to talk about for concept 1. Any questions, just let me know in class. I can help you, or email me. Concept 2, magnitude. The magnitude of a vector is the hypotenuse. So that's really just if you have the two components, which happen to be the legs of a right triangle, and right here, A and B, those are the components, and they happen to be in the x and y coordinate system. They're aligned to the x and y axis. The magnitude is the hypotenuse of that triangle. This is a right triangle. And so what that means is, to find the magnitude, C, you can use Pythagorean theorem, and you know that it's the square root of the legs, or the components, added together, squared and then added together, the sum of the squares of the components, and that gives you the magnitude. This works, this is a two-dimensional triangle. This works in 3 dimensions. If you have x, y, and z axis, so here's positive x-axis, positive y-axis, and then if you can picture this kind of going into the page, so that's sort of 3D, if you can picture that. Z-axis comes out of the page, and so let's say we have components that go like this way. This is component A, we'll say, and then that's in the positive x direction, and then a component in the maybe the positive y direction straight up, and we'll call that B, and then maybe a component going back in the negative z direction, we'll call that C. Then the resultant, or the sum, or the magnitude, you could say, all those work, of these 3 components. Let's do that in green, no, yellow. We'll call that D. D is the square root of a squared plus b squared plus c squared. So you get the x component, the y component, and the z component. And of course, if you were to go into 4 dimensions, which I don't know why you would, because we don't live in a 4 spatial dimensional world, and you could do E equals a squared plus b squared plus c squared plus d squared. Still works mathematically, but it's kind of meaningless. So yeah, that's the second concept. I think I can fit one more in, and I'll put the rest in a second video. I might be able to just do this in 2 videos. Vector addition. So when 2 vectors are parallel, then we'll call this A vector, which equals, let's say, 7 meters. And we have a B vector, which is 3 meters. If they're parallel, you can just do A vector plus B vector equals 7 meters plus 3 meters equals 10 meters. Literally, you can take this, let's see if I can do this here, and just stick it here and add them together. 7 plus 3 is 10. So the length of this line is 10. That's why you can do it early. But if you have, let's try something like this. Let's see if this works. If you have, whoa, that, you can see that this plus this, which really, when you add them together, it's you got to take the beginning point of one vector and the end point of the other vector and draw a line between them. The length of this line is less than 10, all the way to, now you can do that all the way to this. Well, let's just go back here. To where B, whoops, Control Z. You can do that all the way to where B is in oops, the negative direction. And you can see when you add those together, if you put the, I'll do it in blue. If you put the, oops, Control Z, the beginning of the first vector, and you draw a line to the end of the second vector, and connect those, then you get this vector. That's actually 7 minus 3 is 4. So in that sense, you can add them algebraically because they're still parallel. It's just one is anti-parallel. And but when they're not parallel, you have to use trigonometry essentially. So what you do is, let's go back here. Make this like that. What you do is you take the components of these in the x and y axis. Luckily, or coincidentally or fortunately or whatever, I have A already in the x-axis only, but B is not. So if I break B up into its x component, cause bx, and I break into the y component here, by, and sorry for the messy writing under here, but this is just normal b. So the hypotenuse here is 3. I can easily, using SOHCAHTOA, figure out bx and by, and then what I do is I can add a plus bx because they're parallel. That's like 7 plus something that's smaller than 3, maybe 2.5, depending on what the angle is. And that gives us our x component in the x direction. And then we take the y component in the y direction, and we just make a new triangle where this leg is a plus bx, and this leg is by. We do Pythagorean Theorem, and you get the sum of it. That's vector addition for non-perpendicular lines. I'll do an example of this from the book at some point. Alright, that's about approaching 15 minutes, so let's put the other 3 concepts into a new video.